Hello guys, welcome back to my channel. So today we'll be solving question number 15 and onwards of 5070 paper 1 variant 2 May-June 2023. And the last question we had done was question number 14 and its answer was C, positive 238 kilojoules per mole. Alright. Question number 15. What is the best way of slowing down the reaction between magnesium and sulfuric acid? Alright. So, we know that adding a catalyst to the reaction will increase the rate of reaction. So, this won't be the answer. Diluting the acid used in the reaction, okay, this would decrease the concentration. So, concentration would be decreased, due to which rate of reaction would be decreased. So, this would be our right answer. But let's also, see the remaining options as well. So, see, stirring the reagent. So, stirring would cause more, the particles will be moving more rapidly, I may say, because we have stirred them, due to which their kinetic energy would be increased and um, more collision would occur, and therefore successive collision would also increase. So, this is also incorrect. Using magnesium powder instead of a strip. So powdered magnesium means larger surface area, so it is also. Okay. So question number 16. The volume of gas produced by the reaction of 100 centimeter cube of hydrochloric acid with an excess of calcium carbonate is measured in 2 experiments. The volume of gas the volumes of gas are measured at RTP, and the results are shown below. Which one change in the conditions to experiment 1 gives the result for experiment number 2? Assume all other conditions are unchanged. Alright. Let's see. Here in experiment number 1, okay. You can see the trend as the time is increased. As the time is increasing, the volume of gas produced is also increasing. But in both experiments, experiment number 1 and experiment number 2, we can see that after reaching 180 until 300, which means 180 to 300, the gas of volume produced remains constant. Sorry, the volume of gas produced remains constant. Right? But the difference between both the experiments is that the rate of reaction is higher. How I can say that? Here, if I take the value for 30 seconds for experiment number 1, so it is 20 over 30. The rate equals to volume of gas produced over time. So if I see 20 divided by 30, that would give me 0.66. However, this is 0.66. However, if I divide 30 by 30, it would give me 1, which means the rate of reaction is higher in experiment number 2 than experiment number 1. If you have more time, so you can solve further to check it whether the rate of reaction is increasing. But I am telling you, by just comparing the first values, I mean like the values for 30 seconds only, that the rate of reaction in 2 is higher. Okay, so assume all the other conditions are unchanged. So a greater volume of acid is added. Okay, a higher concentration of acid. Smaller pieces of calcium carbonate are used. The temperature of the acid is higher. Okay, so here we can see that at the end we may say that the final volume of the gas produced is also higher in experiment number 2 than experiment number 1, which means not only no that the mass is changed. Oh, sorry, like that the mass of the calcium carbonate is changed, or no? Sorry. Yeah, I'm reading it right. Okay, so I can think it in that way. Um, Smaller pieces of calcium carbonate are used. The temperature of the acid is higher. Yeah, so it means that not only uh, it could be either the change could be in either calcium carbonate or hydrochloric acid. So the temperature is of the acid is higher. It would have just uh, exceptionally, so it would have only increased the rate of friction, not the percentage yield, or sorry, the final volume. I'm sorry. The final volume would have been increased. So this would be incorrect. Same goes with C. Okay, for A and B, let me see. A greater volume of acid is added. Okay, but they're this, saying that the volume is increased. So if the volume was increased, so it could have caused a higher rate of reaction, but not uh, uh, not higher yield of or higher production of the gas. So A would be also incorrect, and hence B is the answer. Okay. All right. Question number 17. Hydrogen is made industrially by the reaction shown. Okay. Statements about this industrial process are given. Okay. One, a high pressure can be used to increase the rate of formation of hydrogen. All right. A higher can, a higher pressure can be used to increase the rate of formation. So we know that pressure acts on gases, and here we only have gases. So yeah, all we have is all we have are gases. So if we look at the molar ratios, one, 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 and one. So 2:2. So the molar ratio is balanced. So the pressure won't be affecting him. One is incorrect. So I'll no wait. Rate of formation. Oh, I'm so sorry. I just got confused with I'm so sorry. A higher pressure can be used to increase the rate of formation of hydrogen. So of course, if the pressure is increased, the volume is decreased, which means that more particles would be present in a smaller area, and they would collide more frequently, more collisions would occur, and therefore more product would be formed. So one is correct. I'm so sorry. One is correct. A high pressure can be used to shift the equilibrium to the right. This one is incorrect. Okay. So obviously the option which have two in it. Okay. So for two, the reason which I gave earlier, that molar ratio reason would be applicable here. Okay. So two is incorrect. Two is incorrect. So A and D would be cancelled out. Alright, a high temperature can be used to increase the rate of formation of hydrogen. Okay, so here we can see that the delta H given to us is in negative. So remember one thing, whatever the value delta H is given to us, it means that it is for the forward reaction. For example, here it is written negative 41, with negative means exothermic, so forward reaction would be exothermic. Okay, and backward would be obviously endothermic. So yeah, so a high temperature can be used to increase the rate of formation of hydrogen. If the temperature is increased, uh, temperature if higher temperature can be used to increase the rate of formation of hydrogen. Yeah, because the collisions would be more frequent, would take place more frequently. Okay, and for fourth, uh, I just told you earlier that as here minus is written, so it would be exothermic. And if they're saying that a higher temperature can be used to shift the equilibrium to the right. So we know that when the temperature is increased, so it shifts the equilibrium to the endothermic side. So here the endothermic side is the left hand side, and they are telling us it's at the right. Well, if we just look at the options, we know that 1 and 3 are correct. So obviously, uh, 3 is correct. Okay, I was just explaining why 4 is incorrect. Okay, I hope it was clear. Question number 18. The table refers to two important industrial gaseous reactions. Here these reactions are given. Okay. Which catalysts are correctly stated? All right. One reaction one is hydrogen plus nitrogen, right? Ammonia. Okay, and nickel. So here you can see this catalyst is incorrect, and they're asking us about the catalyst, right? So here we should write iron. So no is correct. Okay, oxygen plus sulfur dioxide is vanadium 5 oxide. This is correct. So no and yes. So B is the right answer. All right, let's move towards the next question. Iron 2 ions react with chlorine. Which statement about this reaction is correct? Let me zoom in into the version. So here I can see 2 plus and 3 plus. So it's oxidizing. Iron, okay. They are saying that iron 2 ions are the oxidizing agent, which means they are reduced. So this is incorrect. Basically, oxidizing agents are those, are those who oxidizes others but reduces itself. So here we can see that iron 2 plus is being oxidized because its oxidation state is increasing from 2 plus to 3 plus. So this would be incorrect. All right. Iron 2 ions are reduced by chlorine. Okay, we can look into this later. Okay, chlorine is the reducing agent. Reducing agent is the one which is being oxidized uh, and is reducing others. Okay. So here you can see chlorine is reducing itself. Chlorine is 0 here as it's in its elemental form, and here it is -1. So this is also incorrect. Chlorine is reduced by iron 2 ions. Okay. Iron 2 ions aren't reduced. They are being oxidized. So this is also incorrect. So 19A is the correct. Let me minimize it. Yeah. Okay. Which reagent and observation describes the test for a reducing agent? So for reducing agent, we can use aqueous potassium iodide for sure. Sorry, for a reducing agent. Okay. I'm so sorry. They're asking the test for a reducing agent. Okay. So to test whether whether compound or a solution is a reducing agent, we will add an oxidizing agent into it. So oxidizing agent is potassium manganate, and if the solution or whatever the compound is a reducing agent, so what will happen? The oxidizing agent will show a color change, and in the case of potassium manganate, it would be purple to colorless, definitely. So it's B. Okay, can you zoom out a little bit? Yeah. Okay, compound X is a gas at room temperature. X dissolves in water to give a solution with a pH of 4. Let me highlight this point. Which statement about compound X is correct? You have to tell the correct statement. An aqueous solution of X will not conduct electricity. This is incorrect because if you know it's dissolving in water, it means it's polar, right? So polar compound can conduct electricity. I mean, like when it is dissolved in water, so it can definitely conduct electricity. Atoms of a metallic element are present in X. Okay, atoms of a metallic element could be no, wait. We can compound X is a gas at room temperature. So no, it can't have metallic elements, right? This is also incorrect. C atoms of hydrogen are present in X. I'm not sure, but okay, let me okay. C part G. X is ionically bonded. No, as it is a gas at room temperature, that means it is a covalent compound. So no, D is also incorrect. So eventually C is a correct answer. Okay. All right. Question number 22. Which statement about hydrochloric acid is correct? Okay. Hydrochloric acid reacts with magnesium carbonate to form three different products. Let's check it. Magnesium carbonate plus HCl. Sorry, magnesium chloride plus carbon dioxide plus H2O. We balance it to 2 here. So 2 would be written with HCl. So yeah, it's balanced now, and there are definitely three different products. So I would go with A. And just to save my time, I won't be solving these. But okay, let's see. Just for you people, I'm solving. I'm just taking all the three remaining options. Okay. Hydrochloric acid reacts with magnesium to form magnesium chloride and water. It does form magnesium chloride and water, but along with that, it forms carbon dioxide. So this is incorrect. Okay, when hydrochloric acid is added to a colorless solution of thymophthalene, it turns blue. No, turns colorless. Okay. No, sorry, it's thymophthalene. Wait, let me think. Thymophthalene, yeah, it's colorless. Okay. Okay, for D, when hydrochloric acid is warmed with ammonium chloride, ammonia is formed. No. All right, let's move towards the next question. All right. The addition of calcium hydroxide to soil reduces its acidity, but also reduces the efficiency of fertilizers. Which two equations explain this? Okay, so mm, calcium OH2 CO2 gas. Okay, so I would mm, let me check what's happening here. So they're telling if calcium hydroxide to soil reduces its acidity. So basically, you know, an alkaline compound should be produced, right? Okay, so an, an alkaline compound. Wait, the addition of calcium. Oh, sorry. Oh, I think sorry. Yeah, sorry. So it reduces the acidity, right? Which means it would be reacting with acid, and in acids, what reacts? What is basically the reactive thing? It's the H positive ions. You can see here H positive. So definitely 2 would be the correct one. So 1 with 2 is right. 2. The rest of them are incorrect. Okay. Okay. So calcium hydroxide. Basically what it does, it reacts with, uh, ammonium, this is the fertilizers. Fertilizers have ammonium nitrate and, other things. So what it does, the hydroxide reacts with calcium hydroxide would be reacting with the ammonium nitrate and would cause ammonia gas to be released out, of the compound, and ammonia would be removed from the soil. So we know that, and here we see that ammonia is being removed. The react this is these two are reacting, and the result of the reaction is that the ammonia gas is being produced, which would be removed from the soil. So therefore 2 and 3, and yeah, we don't have an option. All right. Which anions are contained in salts that are always soluble in water? You know that nitrates are always soluble in water. Carbonates, not at all. Mostly, uh, yeah. There are few exceptions for chlorides and sulfates. Let's just leave those exceptions. But carbonates, like all carbonates, are insoluble, and all nitrates are soluble. Okay. All right. Question number 25. The element phosphorus P is immediately below nitrogen in the periodic table. All right. It forms an oxide with the empirical formula P2O5. From the position of the phosphorus in the periodic table, the element is expected to be a nonmetal, and the bond and its oxide to be as covalent. Nonmetal and covalent. Yeah. All right. Which statement is correct? Okay. Group 1 elements are less reactive than group 2 elements. Okay. In the same period. In the same period, because they only need to move 1 electron to a complete shell. Incorrect. Yeah, group 1 elements are stored under oil to avoid reaction with oxygen and water in there. We know that because we have seen, sodium, for example, sodium is kept under, a film of oil just to, avoid it reacting from oxygen or water. Okay, we know that. So, B is the correct answer. Let's move to, if for you this time, reading the other parts as well. Group 1 elements become more reactive as the group is descended, cause the number of outer shell electron increases. No, it remains the same. The melting point of group 1 elements decreases as the group is descended, because there is more attraction between positive ions and the C of B liquid. This is also correct. So B is the correct answer. Okay. The table shows some properties of transition elements and the reasons why they have these properties. Which row shows a correct property and the reason why transition elements show this property? Okay. Iron has two common oxidation states, 1 and 2. Iron atoms can use 1 or 2 electrons to form compounds. Okay. Nickel can be used as a catalyst. The use of nickel raises the unknown, or it decreases the activation energy. This is incorrect. B is incorrect. The reaction of aqueous sodium hydroxide oxide with the salt of a transition element can be used to identify the element. Okay, yeah. Transition metals hydroxides are often colored. Yeah. That is correct. You can go through the qualitative analysis notes. You can check copper reaction, sorry, identification test of copper 2 ions, iron of Fe2 plus ions, iron 3 plus ions. That would clarify you. Okay, why C is the correct answer. Okay, let's move towards the next part. All right. Okay. Question number 28. Which equation is correct? Copper 2 plus 2 minus. Okay. First one is true. So, this equation is like, if we check compound is correctly made, but the balancing is not correct. Here we see that two copper are present. There should have been a 2 here, so A is incorrect. For this, magnesium has 2 and BSC4 has 2. This is correct. So, yeah, it's correct. You can even check the rest. So, here I can see it should be Na2O as the oxidation state of oxygen is 2 minus, and for sodium it's plus 1. So, C is incorrect. For the zinc nitrate, zinc is 2 plus. So, there should have been a bracket at 2. So, this is also correct. Alright. Metal X reacts with cold water to form a gas. Okay. Zinc displaces metal Y. Alright, it's kind of vertical. Let me see that again. Metal X reacts with cold water to form a gas. Okay. Zinc displaces metal Y from solutions of its salts. Okay. The carbonate of metal Z is insoluble. Okay. What could be the identities of X, Y, and Z? Okay. It's kind of, very confusing and tricky question. Metal X reacts with cold water to form a gas. So copper isn't that much reactive, so it won't be reacting with cold water just to form a gas. So it would be sodium. Okay. Okay. So C would be cancelled out. All right. Next is zinc displaces metal by. So, mm, so zinc can basically, it can displace copper, okay, from solution of the salts. Yeah, copper. And all carbonates are insoluble, so yeah, it could be copper for sure. And you know that displacing a metal means that zinc would be more reactive than Y. So yeah, zinc is more reactive than copper. So 29 would be B. Yeah. All right. 30. Which statement about alloys is correct? They are compounds of two or more metals. Well, it could be a non-metal as well. They are a mixture of metals with other metals or not. Yeah, this is correct. This is correct. If they conduct electricity because they have ionic bonds between the metal atoms now. They have identical physical properties to the metal, no, not identical, similar. Because it is a mixture, so it would have, kind of similar properties to, the compounds, sorry, the metals or the non-metals from which it is being made. Okay, so B. All right. So that was for today's session. I hope all my uh, solutions were clear enough. And if you still have any problems, so you can comment down and I'll try to resolve your query. Uh, Other than that, please like, share, and subscribe my channel. And till then, have a good time.